That is, shortest time doesn't go with shortest path. Sometimes the information given is indirect. This is a river of width W flowing at VR. A boat is at A with its velocity VB aimed at theta to the banks, and the boat is aiming to go to a point, say B here, but it doesn't land there. It will drift downstream because of the river flow and end up somewhere here. Let's say the distance it drifts down the river is say D. Any problem of a boat crossing the river is a matter of solving two equations, one for the x-axis and one for the y-axis. We set them up like this: x parallel to the river and y perpendicular to the river. The equation for x-axis would be Vb cos theta is the velocity parallel to the river, so Vb cos theta plus Vr into t equals d. Vb sin theta into t is w, the width of the river. This is the equation for the y-axis. Vb, theta, Vr, t, d and w are the 6 parameters here. If you're given 4 of them, you can solve for the remaining 2. Sometimes the information given is indirect, like for example, how far does the boat travel downstream if it crosses the river in the shortest time? Now, this is a bit indirect, so we get to the time part by going here. This simpler equation, w by Vb sin theta, and you can see t will be least when sin theta is maximum, that's 1. When theta is 90, so that t will be w by Vb, right? That's the minimum time. And then the distance traveled parallel to the river, d. This theta is 90, so cos 90, that's 0. That d will be Vr into t. T is w by Vb. This is one case. Theta is 90 and the boat aims its velocity vector towards the other bank but drifts downstream and ends up at distance d downstream from where it started. So the length of the path traveled will be root of w squared plus d squared. Time is shortest here. You can watch an animation showing this, crossing the river in the shortest time. Red and blue arrows represent the velocities of the river and boat respectively. The black arrow is the sum vector. The boat crosses the river in the shortest time in this case. The other possibility is crossing the river along the shortest path. Shortest path is when d is 0. D is 0. That will give us cos theta as minus Vr by Vb. This is the shortest path. Theta has to be so chosen that theta is obtuse, more than 90, such that a component of boat's velocity against the stream will be equal and opposite to the stream velocity. So it will go straight like this. Now, if the time taken to cross here, t equals, w by Vb sin theta, root of 1 minus cos squared theta. Cos squared theta will be square of this, which is Vr squared by Vb squared. And this will give us Vb squared and inside, and Vb under the square root cancels out this Vb. So that will give us w by root of Vb squared minus Vr squared. For this to be possible, for the boat to be able to cross along the shortest path, the value of Vb must be greater than Vr. If Vb is less than Vr, this will be negative square root of a negative number, and that will be imaginary time, so that's not possible. So Vb must be greater than Vr to have for it to travel across the shortest path. So the path length would be W in this case, and you got the time here. Just to get a feel of this, let's say VB is twice VR. VB is twice VR. Will give us the distance traveled, the path length L. The time is W by VB in this case, the shortest time. The path length in that case will be root of D squared plus W squared. And that D will be, VB is twice VR, we said it. This is W by 2, W squared plus W squared by 4. So this is root 5 W by 2. Time is least, and this is the path length. Here the path length is W. Of course, L is W because D is 0 here. And the time is this. And what is that time? W by VB is sine theta. Root 3 by 2 here, so 2W by root 3 VB. 2W by root 3 VB. This was W by VB, and this of course more than 1, right? 2 by root 3 is more than 1. Root 3 will be less than 2, right? So 2 by something less than 2, it's more than 1. Time is more than here. Path length is W. Path length is more here, but time is less. Path length is less here, time is more. Again, I'll show you an animation of a boat crossing along the shortest path. Just get a feel of things. That's it. Hope you enjoyed solving this problem with me. This animation shows the boat crossing the river along the shortest path. The angle between the river and boat velocities is obtuse. Only a component of boat's velocity is useful to cross the river, so it takes longer in this case.